Hello, welcome to CBSE's first personalized chapter model tuition. My name is Aiswarya and today we are here to discuss some important questions from the chapter Matter in Our Surroundings. So let's begin. We have several questions. We are going to start by discussing the MCQs. Okay, see the first question. What is the process of a solid changing directly to a gas called? And we have several options: fusion, vaporization, sublimation and condensation. Now what is the answer? The question asked has process of solid changing in directly into a gas, which means it is not going to the state of liquids, which means the process is sublimation. Okay, so the answer here is option C, sublimation. Now what about option A, B and D? What is A? A is fusion. Fusion is basically melting itself, right? Fusion is basically melting itself where a solid changes into a liquid. A solid changes into a liquid at a particular temperature. What is vaporization then? Vaporization is the process of changing or conversion of liquids into gases. Liquids to gases also at a particular temperature. We call that boiling point, right? And this is called the melting point. When solid changes to liquid at a particular temperature, we call that melting point. Okay, now what is option D? Option D is condensation. Condensation we might know, right? Condensation is the process of conversion of gases to liquids. Conversion of gases to liquids is called condensation. Okay, so we have the answer here as option C, sublimation. The solids directly undergoing the process to get converted into gas. Okay. Now see, the question 2. Which of the following has the highest kinetic energy of particles? Now we know that kinetic energy is related to temperature. Also, kinetic energy is the energy associated with movement of particles. And movement of particles is associated with the space they have in between them. Right? So, if some particles have greater space between them, large amounts of space between them, you can say they will have the highest kinetic energy. So, when comparing the space between particles of solids, liquids and gases, we know that particles in solids are tightly packed. They are closely packed, and in liquids they are moderately tightly or moderately loosely, we can say. It's not tightly packed, it's loosely packed. And comparing to solids, they are loosely packed, right? So we can say liquids, the particles are not very tightly packed, they are loosely packed. In gases, the particles are very loosely packed, which means they will have the greater spaces between them. The particles of gases will have higher space between them or larger spaces between them, which means they have got enough space to move. Enough space to move means they have higher kinetic energy. So gases have higher kinetic energy when compared to solids and liquids. So the answer here would be option C, gas. Now what is option D? All have the same kinetic energy. That's not true, right? We said solids do not move much. They simply vibrate, right? Solids simply vibrate, staying on their own position. Liquids can slide past each other, but the liquid particles can slide past each other, but then gases have more space compared to liquids, gaseous particles, and that's why they have higher kinetic energy. Okay, now moving on to the question number 3. A substance shows negligible compressibility, fixed volume, but no fixed shape. It must be. What are the conditions given? A substance shows negligible compressibility, fixed volume, but no fixed shape. No fixed shape means it is not solids, right? These categories fall for solids also. Solids have negligible compressibility, solids have fixed volume, but then solids also have a fixed shape. So who is this person having negligible compressibility, fixed volume, but no fixed shape? that is liquid. Solids have negligible compressibility, fixed volume, but it also has fixed shape. Liquids have negligible compressibility, fixed volume, and no fixed shape. Gases, they have larger compressibility and they do not have a fixed volume. They do not have a fixed shape as well. And plasma is basically ionized gas, you can say, and ionized gas where you have free charges, free negative charges, free electrons, and positive charges as well. So our answer will be option B, liquid. Okay, moving on to the fourth question. See, latent heat of fusion is the energy required to change 1 kilogram of a solid to a liquid at its latent heat of fusion is being asked, and it is the energy required to change 1 kilogram of a solid into its liquid at its dash point basically. So we have four options: boiling point, melting point, freezing point, and room temperature. Now what is the answer? It is melting point. Solid changes to a liquid at a particular temperature called melting point. So then what is boiling point? Boiling point, option A. So the answer here is option B. We got it. What is A? A is boiling point. What is boiling point? It is the temperature at which liquids get converted into gas. Right? It is the fixed or the proper temperature required, a particular temperature required to convert liquid into gas. And freezing point comes to play in the process of solidification. What is solidification? A process of conversion of liquids into solids. In that process, liquids get converted into solids at a particular temperature called freezing point. So that is freezing point. Boiling point is different. Answer here would be melting point. Okay. So option B is the answer. Now see the fifth question. Which condition will increase the rate of evaporation the most? Which condition will increase the rate of evaporation the most? We have four options. A is low temperature, high humidity, low surface area. B is high temperature, low humidity, large surface area. So we are comparing between temperature, humidity and surface area. There is one more factor, wind speed. We are not talking about wind speed here. Okay. Now what is option C? High humidity, low temperature, high surface area. And option D is low humidity, low temperature, low surface area. Now what is the answer? It is option B. What is the condition required? What are the conditions of temperature, humidity and surface area required? Evaporation, the rate of evaporation increases when you have higher temperature. High temperature means higher rate of evaporation. Why? When you have enough temperature, what happens to the particles at the surface? They will get enough energy to get converted into gaseous state, which means higher heat energy implies higher temperature, implies more particles getting enough energy to break free from their force of attraction, which implies greater rate of evaporation. Okay. Now, what is low humidity? Humidity is the amount of water vapor in air, right? Humidity is the amount of water vapor in air. So, if there is already a lot of water vapor in air, which is implied by higher rate of humidity or higher humidity. So, if you have higher humidity, what you are telling, you are basically meaning that you have greater amounts of water vapor already present in air. Now, more water vapor is already present in air means it doesn't allow more water vapor to come from the water particles or any particle that is going to get evaporated. This higher rate of or higher amount of water vapor already present in air, they will not allow more water to get evaporated or more particles to get evaporated. So higher humidity will decrease the rate of evaporation. So you need low humidity, which means lower amounts of water vapor in air. And then see what is the next condition? Large surface area. Surface area should be increased for greater rate of evaporation. Surface area increases means the amount of or the number of particles on the surface increases, which means those particles can get evaporated because evaporation is a surface phenomenon. Only the particles at the surface gets evaporated. You can say when you have larger surface area, you will have more number of particles on this large surface area. You can say larger surface area means more particles are present on the surface than a surface with a small surface area. Here you will have lesser number of particles on the surface. So when you have more number of particles on the surface, it will automatically increase the rate of evaporation, which means large surface area also increases the rate of evaporation. Okay, so the answer here is option B. All the other options are just to confuse you. Okay, so it's option B. High temperature, low humidity, large surface area. Okay, now see the next category of questions we have. Short answer questions, which basically is for 2 marks. So you'll have to answer for 2 marks. Okay. See the first question from that section. Why is it advised to wear cotton clothes in summer? Why is that so? Basically, cotton clothes are something that can absorb a lot of water. They can easily absorb more amounts of water. Or you can say they can absorb more sweat. See, we perspire in summer to keep our body cool, which means that's a mechanism by which our body keeps ourselves cool. The perspiration process, which means we sweat a lot in summer. Okay, now what does this cotton cloth do during summer seasons? Cotton absorbs sweat and exposes it to air. So cotton clothes act as a method for the sweat to get absorbed by the sunlight, you can say, or by sweat to be exposed to the air by letting it, or you can say, and then letting it to get evaporated. So you can say cotton absorbs sweat and exposes it to air, basically acting as a medium to absorb sweat from our body and exposing it to air so that it can easily get absorbed or easily get evaporated to the air. Okay, it can easily get evaporated to the air, helping in easy evaporation. Okay, what did we just say? In summer seasons, we perspire a lot. And when you wear cotton clothes during summer seasons, cotton is a good absorber of water, which means it is a good absorber of sweat as well. It absorbs the sweat from the body and exposes it to air so that the sweat molecules or sweat particles or the water particles can be easily evaporated. So the rate of evaporation increases. Now see, since evaporation absorbs heat, it cools our body. Evaporation needs a certain amount of heat. It takes this heat or it absorbs this heat from the surroundings, leading to cooling effect of evaporation. Now, since our body is also a surrounding for this water or for the sweat to get evaporated, what happens in this process of evaporation? Absorbing latent heat of vaporization. Latent heat of vaporization is the heat required to convert water particles into our vapor, or it is the energy or heat required for evaporation. Okay, now as this heat is absorbed from the surroundings include our body as well, it cools our body. Evaporation of sweat cools our body. Okay, so that's why cotton clothes are advised. Now, if you wear some synthetic fibers or anything during summer, what happens? They are not good absorbers of water. So they are not good absorbers of sweat as well. And all the sweat remains in our body and it irritates us. It doesn't get evaporated. It doesn't cool us. Okay, so that's the reason why we use cotton clothes. All right, so that was our question 6. Now let's move on to question 7. Explain why a desert cooler cools better on a hot, dry day. Now, why does a desert cooler cool better on a hot, dry day? On a hot, dry day, the rate of evaporation increases. Hot, dry day is being given. Hot means temperature is high, right? Hot means temperature is high, and dry implies humidity is high. right? Humidity is low. Humidity is low, which means it's dry. So you can say humidity is the opposite of dry. Okay, which means if you have dry air, you don't have any kind of, like, you'll have low amounts of water vapor in air. And if you have humid air, you will have larger amounts of water vapor in that air. So if it is dry, if the air is dry, it means humidity is less. Now, don't you feel like these are the conditions required for increased rate of evaporation? We need increased temperature and lower humidity for increased rate of evaporation. So on a hot dry day, what happens? Rate of evaporation increases due to the high temperature and low humidity, as we just discussed. Now, more evaporation leads to greater cooling effect in desert coolers. In desert coolers, basically the principle of desert coolers is evaporative cooling. You will have water pads inside these desert coolers which will absorb this, or you can say which will absorb the heat from the hot air that comes inside the desert cooler, and they will evaporate. Okay, so what is happening? Hot air comes into the desert cooler from the desert areas or from hot areas. What happens? The hot air comes inside the desert coolers, and you will have water in that, or water pads in that desert coolers, which will absorb heat from this air to get converted into water vapor, basically get evaporated. Okay, in that process, what happens? Heat is absorbed from the hot air, which means hot air is not hot anymore. It gets cooled down, and that cool air is given out. Okay, so what happens? The hot air goes inside the desert cooler. You will have water pads inside the desert cooler. They will absorb the heat from the hot air, making the air cooler, and this air is released. This air is given out. The cooler air is given out. So evaporation is going on inside the desert cooler, whose rate will increase if you have a hot and a dry day, because rate of evaporation increases due to high temperature and lower humidity. Okay, so that was our question 7. And see the question number 8. Differentiate between evaporation and boiling. We know that evaporation and boiling result in the same effect, right? They both have the same effect. They both result in liquids getting converted into vapor. But then the processes are different, right? The processes, how they undergo and how the particles undergo evaporation and boiling is different. And the, you can say the heat required is different. All of these are different, right? So you can write different different points regarding the differences, okay, between the processes of evaporation and boiling. Now, see the first point. Boiling occurs at a fixed temperature. Evaporation occurs at any temperature. Boiling occurs at a fixed temperature means boiling occurs at a fixed temperature. A liquid needs to reach a particular temperature so that it can boil, and that temperature was called boiling point. That temperature was called boiling point. So boiling requires the liquid to reach a particular temperature called boiling point, while evaporation occurs at any temperature. Evaporation occurs at any temperature. Okay, evaporation can occur at any temperature below boiling point as well. All right. Now, so that's the first point. Boiling requires a fixed temperature. Evaporation can occur at any temperature. Now see the next point. Boiling is a bulk phenomenon. Boiling is a bulk phenomenon. Basically, for example, if you are taking a beaker full of water, all water particles in that beaker will boil. Okay, they can all boil. But then evaporation is a surface phenomenon. Same thing, you are taking a you are taking a beaker full of water. Only the particles on the surface of that beaker will evaporate. Only the particles on the topmost surface will evaporate. Nothing happens to the particles on the bulk. You can say bulk means inside the beaker. Okay, so boiling is a bulk phenomenon. Evaporation is a surface phenomenon. Okay, now see the next point. Boiling requires heating. Evaporation may use heat from the surroundings. Boiling requires heating. we need to heat the particular liquid so that it can get boiled, so that all the particles will get enough energy to break free from the force of attraction they have between the other particles. Okay, so boiling requires heating. Now, what about evaporation? Evaporation occurs only for the molecules or particles at the surface, and evaporation may use heat from the surroundings for this. So only lesser number of particles are getting evaporated when compared to boiling. Also, this evaporation doesn't require a lot of heat to occur, which means the force of attraction between the particles at the surface is less. Okay, so this heat can be obtained from the surroundings. You don't need to externally heat the liquid so that it can undergo evaporation. Okay, so evaporation may use heat from the surroundings. All right. Okay, so those are the 3 points. Now you can add other points like boiling is a rapid phenomenon. You simply keep, for example, water for heating, water for boiling, you heat it and it will boil. But then for evaporation, you take the same amount of water and keep it for evaporation, it will be a long process, which means boiling is a rapid process and evaporation is a slow process. Evaporation is a very slow process. It is dependent on the different conditions as we talked about: temperature, humidity, wind speed, surface area, all of these. Okay, so it's typically slow. Okay, so these are the different points of differences, you can say, between evaporation and boiling. Okay, now see the ninth one. A diver is able to cut through water in a swimming pool. Which property of matter does this observation show? A diver is able to cut through water in a swimming pool. We have seen people diving in water where he or she is able to cut through the water in a swimming pool, right? Which property of matter does this observation show? Now, this observation shows that particles of matter have spaces between them, and here the diver is able to cut through water in a swimming pool, which means we are going to talk about the spaces between the particles of liquids. We know that they have considerable space between the particles, right? Diver can easily pass through water because the particles of water are not tightly packed. They are loosely packed, as we discussed before, right? Liquid particles are loosely packed when compared to solid, so they can slide past each other, we said, right? And that's the reason why a diver can slide past the or slide through the water in the swimming pool, and the spaces between them allow movement. Spaces between the water particles allow movement of other particles between it. Okay, between those particles. All right, and that's the reason why a diver is able to cut through water in a swimming pool. Okay. All right. Now see question number 10. How is the kinetic energy of particles related to temperature? How is kinetic energy related to temperature? We said kinetic energy is related to, or you can say particles have higher kinetic energy basically because of their movement, and if you have larger spaces, you can move, and so you will have more kinetic energy. Now, you can say kinetic energy of particles is also related to or is also dependent on temperature. Now, as the temperature of a substance increases, what happens? It will gain more energy. More energy means it will move faster, means kinetic energy increases. So, as the temperature of a substance increases, kinetic energy of its particles also increases. Particles that start vibrating with a greater speed. As a result, they can move freely. And this is the reason why they will get converted into different states as well. Okay, as they vibrate much more with much more temperature, much more kinetic energy, and they are vibrating faster, ultimately they will get converted into other states of matter. For example, solids. Solid particles do not vibrate much. Like you can say, they do not move much. They vibrate, staying on their own positions. And as you increase the temperature for that solid substance, what happens? They will start vibrating with greater speeds. And ultimately, as you increase the temperature, what happens? Ultimately, they will be moving freely. getting converted into the next state of matter called liquids. Okay. So particles start vibrating with greater speed, and as a result, they can move more freely. All right. Now, see the next question. Now we have a lot of very short answer questions. See the first one. Define matter. Very easy. Matter is anything that has mass and occupies space. For example, you can write anything that you see around you that has mass and space. Now, sound, light, all of these are forms of energy. So you can say they are not considered matter. Okay. Also, you can say thoughts, feelings, emotions, all of those take up a lot of space in our head, but then they are not considered matter. Okay. So that is question number 11. Now, what is question number 12? What is the process of intermixing of particles of two different types of matter on their own called? This is the definition of diffusion. Diffusion is the process of intermixing of particles of two different types of matter on their own. Now, this is easily occurring for gases and liquids. Solids, it is very, very tough. Okay, so the rate of diffusion is least for solids because they are tightly packed, because the particles of solids are tightly packed. The particles of liquids are loosely packed, so they will allow diffusion. Particles of gases are loosely packed, so they will also allow diffusion. Particles of other kind can diffuse with the air or liquids. Okay. All right. So, and also you can say rate of diffusion is also dependent on temperature. As temperature increases, rate of diffusion also increases. Okay, temperature increases means rate of diffusion increases. All right. Okay. Now see the question number 13. What is the boiling point of water in Kelvin scale? We know that there are different scales for like measuring temperature. We have the degree Celsius scale, and then we have the Celsius. We have Celsius scale. I mean degree Celsius scale, and we have the Kelvin scale. We also have the Fahrenheit scale, but then we are not talking about Fahrenheit scale into greater detail in our chapter. We are mainly dealing with Kelvin scale and degree Celsius scale. So in degree Celsius scale, you know that the boiling point of water is 100 degrees. Boiling point of water is 100 degrees Celsius in the degree Celsius scale. Now, what do you do to convert this temperature into Kelvin scale? We will simply add 273. 273 is the freezing point of water, melting point of ice, anything you can say in Kelvin scale. It's equal to 0 degrees Celsius. So 0 degrees Celsius is equal to 273 Kelvin. So 100 degrees Celsius will be equal to 100 plus 273 Kelvin, which is equal to 373 Kelvin. Okay, so that's how you get to this answer, 373 Kelvin. All right. Now see the next question. 14th one. Name the process by which a liquid turns into gas below its boiling point. A process by which liquid is turning into gas. So we have two processes, evaporation and vaporization. Now, below its boiling point means answer is just one, evaporation. Vaporization occurs only at a particular temperature called boiling point. So the answer here would be evaporation. Okay, evaporation occurs at any temperatures. Now, what is the common characteristic of liquids and gases that allows them to be called fluids? We know that not only liquids but also gases are called fluids, right? Both liquids and gases are called fluids. Now, what is the common feature between liquids and gases that lets them be called fluids? What is the property? They can flow. Liquids and gases have particles that are very loosely packed, which means they can slide past each other, which means they can basically flow. Okay, so both liquids and gases are called fluids because they have the ability to flow and are not rigid. Rigidity means the ability to maintain the shape. Ability to maintain the shape. Liquids and gases do not have the ability to maintain the shape. You can say they are not rigid and they are able to flow, and that's why they are called fluids. This property which enables liquids and gases to flow is called fluidity. Okay. All right. So liquids and gases are called fluids. Okay. So that's all with our very short answer questions. Now we are going to move on to some assertion reason questions. Okay. See the first one. Assertion is the smell of hot sizzling food reaches us several meters away. Smell of hot sizzling food reaches us several meters away. Reason is particles of the aroma of hot food have higher kinetic energy and diffuse faster. What is the reason? Particles of the aroma of the hot food have higher kinetic energy and diffuse faster. Now, what do you think is the answer? Option A is true. Smell of hot food reaches you. And then particles of the aroma, the particles that give you the smell of hot food. Hot food means temperature of these particles is high. And as we previously discussed, as temperature increases, they will have higher kinetic energy. The particles will have higher kinetic energy and they will diffuse faster. So temperature is high, which means rate of diffusion is also high, which means assertion and reason are true. So what are the options we have? Both assertion and reason are true, and reason is the correct explanation of assertion. Now, B is both assertion and reason are true, but reason is not the correct explanation of assertion. And C is assertion is true, but reason is false. And D is assertion is false, but reason is true. Now, what is the answer here? Both assertion and reason are true, and reason is the correct explanation of assertion. So, it is option A. Now, how do we explain it? As we just mentioned, when hot food is there, when we have hot food, heat energy increases the kinetic energy of the aroma particles. Temperature is high for hot food. Kinetic energy of the particles increases. Kinetic energy of the particles that give you smell increases. Higher kinetic energy means particles move faster. Higher kinetic energy means particles moving faster and more randomly. More randomly, this rapid random movement causes them to mix with the air particles. They are randomly moving with greater speed, which means they can easily mix with the air particles on their own and spread out quickly from a region of higher concentration. Higher concentration is the food. Higher concentration, the food contains a lot of particles that give you smell, right? So that is the region where you have higher concentration of particles that will give you smell. Okay, higher concentration means higher amount. Okay, so higher amount of particles that give you smell is there. Where do you have that? It is there on the or near the food. And then this particles that give you smell moves quickly from a region of higher concentration to a region of lower concentration. Lower concentration is the air. The surrounding air contains lower amounts of these particles of smell that is there in our food, right? So what happens? The particles that give smell moves from a higher concentration or moves from a region of higher concentration to a region of lower concentration on their own because of the rapid movement they have, because the temperature is high, right? Because they have greater kinetic energy when the temperature is high. This process of intermixing of particles on their own is called diffusion. We are not mixing it. They are simply getting mixed on their own because of their faster movement. Because the particles of hot food have significantly higher kinetic energy than those of cold food, their rate of diffusion is much faster, allowing the smell to travel a greater distance in a shorter amount of time. That's the reason. How do we explain it? We have more kinetic energy for the particles in hot food when compared to cold food, and that's why the smell reaches us several meters away very fastly. Okay, so the answer here will be option A, and this is the explanation you might give. Okay, now see the next assertion reason question. Assertion is liquids have a definite shape like solids. Reason is liquids take the shape of the container in which they are kept. Now both are contradictory statements, right? Either liquids have a definite shape like solids, or liquids take the shape of the container in which they are kept. Now, what does reason imply? Reason says that liquids do not have a particular shape, definite shape on its own. It takes the shape of the container in which it is kept. Now, what is true? Option D is the correct option here. Assertion is false, reason is true. Okay, so it's option D. Assertion is false, reason is true. Now, what is the explanation? As we just mentioned, liquids have no fixed shape, but they have a fixed volume. So, they take up the shape of the container in which they are kept because the particles in a liquid move freely. Okay, so they can move freely because they are not tightly packed. They do not have a fixed shape, but they have a fixed volume. And because of this property, you can say the liquids can move freely and have greater space between each other as compared to solids. Okay, they can move freely and they have greater space between each other, and that's why you can say they have no fixed shape. Alright, so this is how you explain the answer. Answer here is option D. Now see the 18th one, 18th question. Assertion is clothes dry faster on a windy day. And reason is with the increase in wind speed, the particles of water vapor move away from the wind or move away with the wind, decreasing the amount of water vapor in the surroundings. What is the assertion? Clothes dry faster on a windy day. We know that evaporation or rate of evaporation increases on increasing wind speed, right? As we have greater speed for the wind around the particles that gets evaporated, rate of evaporation increases. So rate of evaporation increases, which implies there is greater wind speed, not lower wind speed. Wind is moving faster. So clothes dry faster, which is a result of evaporation on a windy day. So assertion is true. What is reason? With the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surroundings. Moving air is called wind. And windy day means wind is moving faster. Means as water gets evaporated, the moving air or wind carries this water vapor along with it, allowing more and more water vapor to be formed, allowing more and more evaporation to occur. See, what do? They move away with the wind. The water vapor move away with the wind. Water vapor that gets formed by the process of evaporation moves away with the wind. Wind carries it. Since wind carries the water vapor as it is formed, it allows more and more of water vapor to be formed. It decreases the amount of water vapor in the surroundings. Okay, in the nearby areas of the clothes, for example, as given in the question. Okay, so that's why you can say assertion and reason are true. Reason is the correct explanation of assertion. So it is option A. Alright, so the answer for this question would be option A. Both assertion and reason are true, and reason is the correct explanation of assertion. Now read the explanation. On a windy day, the rate of evaporation increases with an increase in wind speed, as we just mentioned. This is because the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding air, which allows more water to evaporate. Okay, so rate of evaporation increases means more and more of water can get evaporated. Okay, because there is higher speed for the wind. Okay, so here the answer will be option A. Now see the next question. Solids cannot be compressed easily because the particles are closely packed. Assertion is solids cannot be compressed easily because the particles are closely packed. What is the reason? Reason is gases can also be not compressed because they expand to fill their container. Now, what is the reason again? Gases can also not be compressed because they expand to fill their container. What is assertion? Is it true? We said solids have negligible compressibility. Why do they have negligible compressibility? Because they are already tightly packed. Particles do not have enough space between them so that they can get compressed. Compressed means particles need to come together by the application of greater pressure. So you can say in solids, particles are already tightly packed, which allows no more compression, which means they have negligible compressibility for solids. What about gases? Gases are loosely packed. Particles of gases are loosely packed, which means they have enough space. So they can very much compress themselves or very much get compressed, and you can say they can undergo this process of compression. So assertion is true because solids cannot be compressed easily. That's true. They have negligible compressibility. So assertion is true. What about reason? Gases can also not be compressed because they expand to fill their container. Now that's not true. Gases can be compressed because they have enough spaces between them, as we have discussed here. So the answer would be option C. Assertion A is true, but reason R is false. How do we explain it? Solids are incompressible due to very little space between the particles. So you can say they are generally incompressible or they have negligible compressibility. But gases can be compressed easily since gas particles have a lot of space between them. Okay, they have a lot of space between them, so they can be easily compressed by the application of high pressure and low temperature. High pressure and low temperature. Now these are the conditions required for compressing gases and liquefying them. All right. Okay, so that was our 19th question. Now see the question number 20. Assertion is solids cannot diffuse. Reason is solids have negligible intermolecular space. Okay, now what is assertion? Solids cannot diffuse. Reason is solids have negligible intermolecular space. Now, the assertion is not completely true. Solids can diffuse, although very slowly. Okay, solids can diffuse through liquids. Okay, and solids can diffuse to other solids like in the case of metals, but those processes are very, very slow. Okay, you can't simply say solids cannot diffuse because they can, but then they are very slow. That process is very slow. Now, what is reason? Solids have negligible intermolecular space. Now, that's true. They have negligible intermolecular space. Intermolecular space between the solids is negligible. It's very low. Very, very low. Okay. Alright. So, we can say assertion A is false and reason is true. So, it's option D. Okay. Option D. Assertion is false. Reason is true. Okay. See, solids have very small intermolecular spaces, making diffusion extremely slow but not impossible. Since particles of solids are very tightly packed, you can say they can they can undergo diffusion, but then the process is very slow. So you can say solids have negligible intermolecular space. Intermolecular spaces are very low, but then you can't say they will not get diffused. They can undergo diffusion. All right. Now, let's discuss some long answer questions which will be for 5 marks. Okay. See the first one. Define matter. This is a very general kind of question that you can have. See, define matter. Classify and explain the states of matter on the basis of shape, volume, compressibility, fluidity, and kinetic energy. So, when such a question comes, we have how many questions to answer? Define matter. Classify the states of matter. Explain the different properties on the basis of shape, volume, compressibility, fluidity, and kinetic energy. So it's like you have 3 sub questions to answer, right? Now what is matter? Matter is anything that has mass and occupies space. You can also write a lot of examples. And then matter can be classified. This is the second question that we are answering. Matter can be classified into solids, liquids, and gases based on the variation in their characteristics of particles of matter. characteristics of particles of matter, we have three characteristics of particles of matter, right? Particles have space between them, particles are continuously moving, and particles attract each other. So you can say basically all particles have space between them, but in the case of solids, what is the thing? They are very much crowded, they are very tightly packed, so they have very minimum space between them. All right, okay. Now see the third question's answer. The third sub question is explain the states of matter on the basis of different properties like shape, volume, compressibility, fluidity, and kinetic energy. Now see the case of shape. In when you compare the shape of solids, liquids, and gases, solids have a fixed shape and they have distinct boundaries. Liquids do not have a fixed shape, they take the shape of the container. Gases also do not have a fixed shape, also they do not have fixed volume, and they can take or they can fill the entire container. So liquids take the shape of the container because they have a fixed volume. They can't expand on their own to fill the entire container. But then gases, they do not have a fixed shape, also they do not have a fixed volume, and that's why they can fill the entire container. Okay, so that's about shape. Now what about volume? Volume, as we just mentioned, solids have fixed volume, liquids also have fixed volume, but then gases do not have a fixed volume, and that's why they expand to fill the container. You can take a particular amount of gas in a container and you can close it. The container will be filled with the gas. The gas can expand to fill the container, which means they don't have a fixed shape or fixed volume also. Okay. Now see the third property, compressibility. As we just discussed, particles of solids are very tightly packed, so they don't have more scope to get compressed and bring particles further together. So they have negligible compressibility. They are almost incompressible. And then liquids have very slight compressibility when compared to gases, mainly because of the volume. They have a particular volume and the particles are loosely packed, not like our gases though. Okay, so they have very slight compressibility, and gases, they are highly compressible, basically because of the large spaces the gas particles have between them. Okay, since gas particles have greater spaces between them, they are highly compressible. Particles of gases can be brought together. Also, they don't have a fixed volume, so gases, the gaseous particles expand and move. You can bring them together by compressing. Okay, so that was about compressibility. Now, what about fluidity? See, fluidity we just discussed. The ability of matter to flow is called fluidity. Now, if something needs to be flowed, what happens? It needs some space between the particles, right? In solids, the space is very low. Space between the particles is very low, so they do not flow, you can say. The solid particles do not flow or slide past each other. But then liquids flow easily, and that way you can say they have greater fluidity. And gaseous particles also flow because they have enough space between the particles and they flow very easily. Okay, so fluidity is present for liquids and gases. Now what about kinetic energy? Kinetic energy is also dependent on the space you have between the particles. If you do not have enough space, particles do not move. If they do not move, they don't have enough kinetic energy. So you can say kinetic energy is the least for particles of solids. It is more than solids for particles of liquids. It is the highest for particles in gases. Okay, so that's all about the different properties that were asked here. Shape, and then we have volume, compressibility, fluidity, and kinetic energy. We discussed all of those. Okay, now see the next question. Next question has two subparts. See the part A. Why do solids have a definite shape and volume? That's part A. Part B is describe the arrangement of particles in solids. Okay. Now what is A? Why do solids have a definite shape and volume? Why do solids have a definite shape and volume? Because because the particles in solids have very little space between them. They are Very closely packed. Okay, solids have a definite shape, distinct boundaries, and fixed volume because their particles are very closely packed. Particles are very closely packed, and that's the reason for most of the properties of solids. Solids have a definite shape and they do not move because their particles are closely packed. Okay, now see the next one. The next sub question: describe the arrangement of particles in solids. Describe the arrangement of particles in solids. As we just mentioned, see, in solids the particles are held together with greater force of attraction. They are closely packed and the kinetic energy is minimum. So you can say in solids the particles are held together with greater force of attraction. They have the maximum force of attraction. The particles of solids have the maximum force of attraction when compared to liquids and gases, and that is also one reason why the solids have definite shape. Okay, this increased force of attraction between the particles will not allow the solids to move freely, solid particles to move freely. Okay, so you can say solids particles have greater force of attraction, they are closely packed, and the kinetic energy is minimum, which means they are rigid. They have a definite shape. Rigid means they have the ability to maintain the shape. Okay, so that's all about the question number 22. Now see the question number 23. Explain the interconversion of the three states of matter. When such a question is asked, you need to answer by stating the six processes, the definition of six processes, and also it would be nice if you can draw the triangle. Okay, the triangle could also help you. All right. Now, let's discuss the different processes of interconversion of states of matter. First one is fusion. Fusion is the process of a solid changing into a liquid. As we mentioned, it is like melting. It is melting itself. And it occurs only when the solid reaches a particular temperature called the melting point. And what does this temperature do? It gives the solid particles enough heat energy to break free from the force of attraction they have between their particles, allowing them to move freely, converting them to a liquid. Okay, so the temperature, enough temperature is required. Why is it required? It allows the solid particles to break free from the force of attraction between their particles and to move freely, converting into liquid. Now, what is solidification? Solidification is the reverse process of fusion, right? Solidification, from that name itself, I think it is clear, right? Solidification is the opposite of fusion. You can say it is the process of conversion of matter from its liquid state to solid state at specific conditions of temperature and pressure. Solidification is having a very easy definition. It is the process of conversion of matter from its liquid state to solid state at specific conditions of temperature. It also requires a particular temperature for the liquid to get solidified to form solids, and that temperature is called freezing point. Okay, here for fusion it was melting point. For solidification it is called, that particular temperature is called freezing point. All right, now see the next process, vaporization. Vaporization we already discussed is the process of conversion of liquid into gas. This also occurs at a particular temperature, and that temperature is called boiling point. So you need to heat the liquid to convert it into gas, and it occurs only at a particular temperature. That temperature is called boiling point. And what is this heat doing for our liquids? What is this heat applied for? It is used up to break free from the force of attraction between the particles of liquid to get converted into gas. Okay, see, when a liquid is heated, its particles gain enough energy to break free from the forces of attraction, and the liquid starts changing into gas. Okay, liquid starts changing into gas in the case of vaporization at a particular temperature called boiling point. Okay, now see the next process. So we discussed fusion, solidification and vaporization. Now see the next one, Condensation. Condensation is the reverse process of vaporization. How will you explain condensation? It is the process of conversion of matter from its gaseous state to liquid state at specific conditions of temperature and pressure. Now, what do you need to do for our gaseous state to get converted into liquid state? You will have to cool the gaseous substance, right? Cooling gaseous substance will give you liquid state. Only then the particles will come together to form liquid or to get converted into liquid. Okay. Now see the next one. Sublimation. Sublimation is a different process, right? It is the process of change of state directly from solid to gas without changing into liquid. Okay, it is the process of change of state directly from solid to gas without changing into liquid. And so you need greater amount of heat energy, right? Solid is getting converted into gaseous state without going into the liquid state. So you need temperature, you need higher heat, which means you need to heat that solid to get converted into gas. Heat is required. Okay. Examples of substances that undergo sublimation are iodine, camphor, dry ice. All of these are examples. Also, ammonium chloride is an example. Okay. And you can say naphthalene is an example of something that undergoes sublimation. All right. And you can also use this code called ICAN. I is for iodine, C is for camphor, A is for ammonium chloride, N is for naphthalene. Okay. So that's all about sublimation. And then see the last process. It is deposition. Now what is deposition? It is a reverse process of sublimation. It is the process of change of gas into solid without changing into liquid. You can simply think of it as gas is getting converted into solids and getting deposited. Okay. So solids get deposited, not gases. That's one way you can think of. Okay. Deposition is the process of change of gas to solid without changing into liquid. All right. Okay. Now, see the next question. So, those were the different processes we have. We have 6 processes. And if you are asked generally to answer this question, answer this kind of a question where you need to explain the interconversion of the states of matter, the 3 states of matter, you will have to write all the 6 processes. All right. Now, see the next question, question number 24. Define evaporation. Describe the 4 key factors that affect the rate of evaporation. Now, evaporation we just discussed, right? Evaporation is the process where liquids get converted into gases below its boiling point at temperatures below boiling point. Phenomenon of change of liquid into vapors at any temperature below its boiling point is called evaporation. Now, evaporation is a surface phenomenon as we just discussed. Evaporation is a surface phenomenon where only the particles on the surface will get evaporated. Nothing will happen to the particles inside the beaker. Okay, so only the particles on the surface will get evaporated. Now, beaker, I said for the example of water taken in a beaker. All right. Okay. Now, see, particles from the surface of a liquid gain enough energy to overcome the forces of attraction and change into the vapor state. Only the particles on the surface gets enough energy to break free from the force of attraction they have between the other particles and convert into vapor state. Okay. Now, it can occur at any temperature below the boiling point of the liquid. It can occur at any temperatures basically you can say. And also you can say heat required for evaporation is obtained from the surroundings. You are not externally heating it. You are not supplying heat to the liquid so that it gets evaporated. Evaporation occurs without heating. Evaporation occurs by obtaining or getting energy from surroundings. Okay. Now, what are the different factors affecting evaporation? There are basically 4 factors affecting evaporation. The first one is surface area. As we mentioned earlier, when you have greater surface area means larger number of particles are present on that particular surface. The number of particles on the surface is greater, which means rate of evaporation increases. What about temperature? An increase in temperature increases the kinetic energy of the liquid's particles. Temperature increases the kinetic energy of the particles. Also, it gives them energy to escape or to break free from the force of attraction they have between the other particles. An increase in temperature allows more particles to escape into vapor state, thus increasing the rate of evaporation. Okay, now see the next factor. It is humidity. Humidity is the amount of water vapor already present in air. Okay, so if you have greater humidity means more amount of water vapor is already present in air. But then evaporation is giving you more amount of water vapor, extra water vapor into the air which already has water vapor. Now that's tough, right? So which means higher humidity decreases the rate of evaporation. If the air is already filled with water vapor, the rate of evaporation decreases. So lower humidity increases the rate of evaporation. Okay, now what is wind speed? Wind speed is our fourth factor that affects evaporation. Now, how do we explain wind speed? An increase in wind speed increases the rate of evaporation. As we just discussed, wind speed, wind is moving air. Wind speed is high means moving air, like wind is or air is moving with, or you can say air is moving faster. If air is moving faster, what does this air do? It takes or it carries the water particles or water vapor particles as it moves, as the water particles get evaporated. See, wind carries away the water vapor, which decreases the amount of water vapor in the surroundings and allows more liquid particles to evaporate. Okay, wind carries away the water vapor. As water vapor is formed or as water gets evaporated, wind carries this water vapor. Now, it decreases the amount of water vapor present in that surrounding, right? In that surrounding, amount of water vapor present will be less if wind carries all the water vapor that is formed. Okay. Now, if there is less water vapor in the surroundings, it will allow more evaporation, thus getting more water vapor in the surroundings. Okay, so it will allow more liquid particles to evaporate. So, increased wind speed also increases the rate of evaporation. So we have four factors: increased surface area, increased temperature, lower humidity, increased wind speed that affects the rate of evaporation. Okay. Now see the question number 25. Describe the importance of latent heat in the change of states of matter. Now latent heat is very important, right? Latent heat is important. Why? Latent heat is the heat energy absorbed during a change of state of matter without any change in temperature. So it is the heat energy absorbed, but it doesn't reflect in the thermometer because the temperature is not changing. Now, why is this latent heat important? It is important because it helps substances overcome the force of attraction between their particles. Particles are held together by the force of attraction between other particles, from the other particles, right? We said that is a characteristic feature of the particles of matter. Particles attract each other. So, you need to break free from this force of attraction in order to move to the next state of matter. For example, solid particles are attracted very much. Attracted, like you can say the force of attraction in solids are very high. Maximum it is. Now, in order to convert the solid particles into liquids, what do you need to do? You need to absorb, the solid particles need to absorb heat energy and break free from the force of attraction they have between the other particles to move freely and get converted into liquids. Okay, so it is important for the change of states of matter to overcome the force of attraction. Now, latent heat of fusion is the amount of heat energy required to change 1 kilogram of a solid into liquid at its melting point without any change in the temperature. This is the definition of latent heat of fusion. Okay, latent heat of fusion is the amount of heat energy that is required to change 1 kilogram of a solid into liquid. You can simply say it is the heat required to change solid into liquid without any change in the temperature, which means if for example you take ice at 0 degrees Celsius, ice melts. Melting point of ice is 0 degrees Celsius. 0 degrees Celsius remains the same until all the ice gets melted to form water. So temperature is same, but then heat is absorbed. What is this heat being used for? It is used for breaking free from the force of attraction that the ice particles have. Okay, so ice at 0 degrees Celsius absorbs latent heat of fusion to change to water, but its temperature remains constant until all the ice melts. Okay, all the ice melts, which means that heat energy is used up by the ice. Okay, now, what about latent heat of vaporization? Latent heat of vaporization is the heat energy required to change 1 kilogram of a liquid into gas at atmospheric pressure at its boiling point without any change in temperature. Latent heat of vaporization is also the same concept, but here it is the heat required to convert liquid into gas at the same temperature. Temperature doesn't rise. For example, water particles get vaporized at 100 degrees Celsius. At this temperature, water absorbs latent heat of vaporization, or water absorbs heat energy to break free from the force of attraction it has with other water particles to get converted into gaseous particles or to get converted into steam. And temperature doesn't rise until all the water gets converted into steam. Okay, particles in water at 0 degrees Celsius have more energy than particles in ice at the same temperature because of latent heat of fusion, and particles in steam at 100 degrees Celsius have more energy than water at the same temperature because of latent heat of vaporization. Now, why is that important? It is because, like, for example, if you are considering water at 0 degrees Celsius, ice uses up all the heat energy that it gets, but then water is not using the heat energy. Water, once it is once all the ice, like once ice is getting converted into water, water absorbs the heat and water is not using up that energy to break free from the force of attraction it has. That energy is not enough. It needs more heat energy, right? It needs to reach 100 degrees Celsius. So at 0 degrees Celsius, water will have more energy when compared to ice. Ice is using up all the energy it has. And you would obviously know that at 0 degrees Celsius, we have both water and ice. You can say both solid and liquid state present at 0 degrees Celsius. And at 100 degrees Celsius, you have both liquid and gaseous state present. Both water and water vapor present. Okay. At 100 degrees Celsius means at boiling point. Okay. And 0 degrees Celsius is the melting point. Okay. And similarly, if you consider the energy of steam and water at 100 degrees Celsius, energy of particles in steam is greater than the particles of water. Why? The particles of water uses up the energy that they absorb. But then steam is not doing that. Steam is chilling, absorbing the energy, which means steam is not using up any energy that it is absorbing, which means steam will be having more energy at the same temperature. Okay, so same temperature, but the energy is different. That's it. Okay, all right. Now, see, latent heat is essential for understanding the process of change of state of matter and has practical significance in daily lives. Latent heat is very important because this latent heat allows us to understand, like, how or what happens in a particular process of change of matter, and has practical significance in daily life. Especially we have learnt examples of cooling effects of evaporation where latent heat was important. Okay, all right. Now let's move on to the case study questions. We have 5 case study questions also to be discussed. See the first one. When camphor is heated, it changes directly from solid to gas without passing through the liquid state. When camphor is heated, it changes directly from the solid to gas, from its solid state to gaseous state without passing through the liquid state. That's the case. What is this process called? Now it is easy, right? Process of conversion of solid without changing into liquid to gas is called sublimation. So the answer for the first question will be sublimation. What is the number 2 question? Give one more example of a substance that undergoes sublimation. We discuss a lot of examples, right? You can write any of those. Iodine, naphthalene, ammonium chloride, dry ice, all of these can be written. Now see the third question. What is the reverse of the above process called? Reverse of sublimation is called deposition, as we discussed earlier. Deposition is the process of conversion of gas directly into solid without going into the liquid state, without passing through liquid state. Okay, so that was our first question. Now see the second case study question. A balloon seller uses a single gas cylinder to fill a large number of balloons. From one cylinder, he can fill many balloons of different sizes. This shows that gases can be stored in cylinders and later used to fill objects like balloons. Now, what is the question? Why can one cylinder fill many balloons? Why is that so? It is because large volumes of gases can be stored in cylinders because gases do not have a fixed volume. Large volumes of gases can be stored in cylinders because gases do not have a fixed volume. Also, they can be compressed. Gases have higher compressibility. So they have greater compressibility and they do not have fixed volume, and that allows larger volumes of gases to be stored in cylinders. Okay, now see the second question. Name two gases commonly supplied in cylinders. That's very easy. You can simply write LPG and CNG. LPG is liquefied petroleum gas, where gas eventually gets converted into liquid. Okay, gases are compressed to an extent where it gets converted into liquid. But then compressed natural gas is where the natural gas is compressed to fill a cylinder, but then it's still in the gaseous state. Okay, compressed natural gas, the CNG cylinders have CNG or compressed natural gas in the gaseous state itself. Okay, in LPG, it is in the liquid state. All right. Okay, now see the third one. What property of gases makes this possible? See, high compressibility of gases makes this possible. The conditions required for compressing gases are application of high pressure and low temperature. High pressure means particles come together. Low temperature means their kinetic energy will be low, so their movement will be slow, which means they can be brought together easily, which means they can be compressed easily. Okay, so the reason for this large volumes of gases being filled in a container or filled in a cylinder is their higher compressibility of gases. Okay, now see the next question. During summer, many people store drinking water in earthen pots. It is observed that water kept in these pots become cooler than the water kept in metal or plastic containers. The water inside becomes pleasantly cool and refreshing to drink in an earthen pot. Why does water kept in an earthen pot become cool in summer? What is the reason for that? Water kept in an earthen pot becomes cool in summer because of the phenomenon of evaporation. Now, we are not explaining what is evaporation here because basically we are explaining that in the next question. Okay, so that's why we are simply writing evaporation here. Alright, so why is the water being cool in earthen pot? It is because of the phenomenon of evaporation. Now see the second question. What special feature of the earthen pot helps in this cooling? What is the special feature in the earthen pot? Earthen pots are made up of clayey soil. And the property of clayey soil is that they have tiny pores. The clayey soil have tiny pores. And those tiny pores in earthen pots helps in the cooling. What do? Water inside the earthen pots absorbs energy from the pot as well as the other water particles in the pot to evaporate through the pores, making water inside the pot cooler. Water eventually tries to evaporate and they have favorable conditions since the pot itself has got a lot of pores in it. What happens to this water? Water absorbs heat from the pot as well as the other water particles inside the pot to break free from the force of attraction it has with the other particles and evaporate through the pores, not seeping through the pores. It is getting evaporated through the tiny pores. Okay, so that's how our earthen pot gets cooled down, or the water kept in earthen pot gets cooled down. Okay, which type of day, the third sub question, which type of day, hot, dry or humid, will make the water cooler more effectively? Now this question is also based on the factors affecting evaporation. You need to answer this dealing with the factors affecting evaporation. We know that rate of evaporation increases on a hot day because temperature increases, and rate of evaporation increases on a dry day because humidity is less on that day. For humid day, rate of evaporation is less because water vapor is also always present or already present in that air, so it doesn't allow more water vapor to be formed. A hot, dry day would make the water cooler more effectively as rate of evaporation increases on increasing temperature and decreasing humidity. Okay, a hot, dry day would make the water cooler more effectively as rate of evaporation increases on increasing temperature and humidity. Okay, now see the next question. Neha was cleaning her nails and with nail polish remover which contains acetone. That's why it has got that particular smell. Okay. She noticed that as soon as some drops of acetone fell on her palm, the skin felt cold. Within a few seconds, the liquid spread and disappeared from her skin. Okay, so we are talking about acetone. Acetone fell on Neha's palm and skin felt cold. As soon as it fell on her palm, skin felt cold. Within a few seconds, the liquid spread and disappeared from her skin. Why did Neha's palm feel cold? It is because of the cooling effect of evaporation. Our acetone is getting evaporated here, absorbing energy from the palm. So Neha's palm felt cold because acetone absorbs heat from the palm to change into vapor. Evaporation occurs by absorbing heat from the surroundings, and here Neha's palm is the surrounding. Okay, now see the next one. Name two more substances which show a similar effect. Like when you pour it into a palm, it will also evaporate easily, giving you a cooling effect. Two more substances that does this. See, the examples are alcohol and perfume. Alcohol and perfume, if you drop it in your hand, what happens in your palm? It will evaporate, absorbing energy from the palm. All right. Now see the third question. Name the process responsible for the disappearance of acetone from Neha's palm. We are only asked to name the process. It is evaporation. You can also explain it. You can also define it if you want. Okay. Simply you can write it is the process of conversion of liquids into vapors below its boiling point, absorbing heat from the surroundings. Okay. All right. So let's discuss the last question we have. See, particles in steam at 373 Kelvin have more energy than water at the same temperature. This is a statement that we just discussed from our long answer questions, right? Now, see the first question. Define latent heat of vaporization. What is latent heat of vaporization? It is the heat energy required to change 1 kilogram of a liquid into gas at atmospheric pressure at its boiling point without any change in the temperature. Okay, so that's the definition of latent heat of vaporization. Now, what is the second question? What is the boiling point of water in Celsius scale? So, boiling point of water at Kelvin scale is given 373 Kelvin. How do you convert this temperature given in Kelvin scale to Celsius scale? You subtract 273 from the given value. You will get 100 degree Celsius. Okay, so 100 degrees will be the answer. Now, see the third one. What type of process is boiling, bulk or surface phenomenon? Boiling is a bulk phenomenon. Evaporation is a surface phenomenon. Now, why do we say boiling is a bulk phenomenon? Because we are heating it, right? We are heating a liquid to get boiled, and all the particles in that liquid will get enough energy to break free from the force of attraction they have between the other particles to get converted into gas. But then for evaporation, Only the particles on the surface will get enough energy, and that too from the surroundings. Okay, so that's the reason why we say boiling is a bulk phenomenon. With that, we are going to an end for the discussion of our, exam material, and I hope everything is clear, and see you. Bye.